this time you should understand. You take any bike or four-wheeler, two-wheeler, or any toy. I think better I suggest you purchase one toy, monster truck, one which will have little bit bigger wheels. No, I think my kids they do play, so I do remember. So like this monster truck will be, no, you just push that, the wheels will rotate. No, the motion of the wheels is nothing but the rolling motion. Or not this one, sir. You take any cylindrical shampoo bottle or any bottle, plastic bottle which is there in kitchen, just throw it on the ground. It starts rotating, no, and also moving. There is a rolling motion. Or you take ball, cricket ball, just push it on the ground, and it starts rolling. That motion is what we are going to study here. Nothing bigger, nothing very big. I'm telling this one. This is what I think you can do now only if you have any pencil, pen. So you just push it that one. No? It starts moving and also rotating. That particular rolling motion we are discussing that one. Or now here afterwards any vehicle moving on the road. Nothing but it is a part of rotation mechanics. Just do make observation. Fine. So this is our the main discussion of this week's syllabus. So rather than confined to book, what happened? Just have a general idea. So it'll be in far more comfortable portion. I feel rotation mechanics by this time you might have felt very easy. The coming topics also you can see that very easiest chapter you can see that one. Once if you can get the reality, you feel this is a very easiest chapter. Okay, let's. There's a one more theoretical, then we'll enter into rolling one. So what is the example of rolling body? So this is the ground and the rigid body is here. So I'm giving some irregular shape so that it is applicable for anything that one. So there's a ground which I'm taking the reference. Now C is the velocity center of mass, velocity of center of mass. VC will write it. And all particles, they're going to rotate about the center. I think this what happens practically. If you take the rigid body which is rolling, sir, where I'm not seeing rolling, rolling doesn't seem rolling of wheel only. It can be any object where translative and rotative motion. What is omega c? Angular velocity of all the particles are rotating about center of mass. And the center of mass is having translative motion. So what is omega c? Angular velocity of the angular velocity with which all particles rotate about center of mass c. Okay, this is angular velocity. And what is VC? VC is the velocity of center of mass. How the center of mass will move? Will move horizontally. And what about all particles? They're rotating about center of mass here. Now, what is its angular momentum about axis passing through point J and perpendicular to plane? So how is the axis now? So here we define this axis here. So about z-axis. So we are going to define angular momentum about z-axis about point G. I want angular momentum of this rigid body about an axis passing through point G, or about origin you can put it. About origin G. I'm writing the ground. Let this be ground. Okay, now I'll give 2 minutes time, analyze it. Because you know enough of concept. Okay, take notebook, pen. Okay, draw the diagram. I want the total angular momentum of this rigid body about an axis passing through point G and perpendicular to plane of diagram. Or nothing but shall I say z-axis. Okay, the position vector of center of mass, let it be RC bar. Let me take the ith particle. Let this be ith particle. Some particle n I can write. Instead that I'm picking up I symbol, that one. So this will be Ri bar, and this is that ith particle. Now, according to the condition what is given, all particles will rotate about center of mass with an angular velocity. So therefore, what can be this distance RIC, position of particle with respect to center of mass, and so what is the linear velocity? Velocity of particle with respect to center of mass. So what is VIC? VIC should be equal to RIC into omega c, and about center of mass they're rotating. Let's see what further I can write it here. Now let's write the one small. What is the mass of this ith particle? Let it be mi. Mass of the total rigid body, let it be m. What is the momentum? I think this particle, velocity of particle with respect to center of mass, no, VIC. What is high c? Velocity of particle with respect to center of mass. No. What is the momentum with respect to center of mass? Should always be zero. So therefore, I'm writing MIVIC is equal to this much here. So let's do one thing. Before that, what is vector? How you write it? RIC bar, RI minus RC bar. What is velocity of ith particle with respect to center of mass? VI bar minus VC bar. Let's define the angular momentum of this particle with respect to ground. And what is VI? Velocity of ith particle. This is very important. It's I think in most of our books it's not available, but the whole concept revolves around this one, because any conceptual question, if they ask you, no, we need this thinking. I would have written directly one formula, then that formula how to use I would have shown. But if they ask you any conceptual, you can't manage with formula. You must know how that form has come. That's why I'm trying to derive it here. No? What is the angular momentum of this ith particle with respect to ground? I think by this time everyone know center of mass of rigid body. I think I defined all the parameters here. No, let's write the all one by one equations here. So angular momentum of the ith particle with respect to ground about an axis passing through G and perpendicular to plane of paper. What is the basic formula? Ri bar cross Mi Vi bar, R bar cross P bar, or R bar cross MV bar. Then I want the total angular momentum. So therefore what we do, summation of DLG is equal to summation of MI RI cross VI. Okay, let's substitute all the quantities one by one. So this should be equal to summation of what is RI? RI, I'll write it as RIC plus RC bar. From this diagram, from this equation. Ri bar, what you can write, RIC bar plus RC bar. Cross. Vi, what you can write, VIC bar plus VC bar. I think we have to go back to our ideas of center of mass. Let's expand this formula. If I expand this, What all I get? One quantity mi ric cross vic mi cross vc summation of mi rc cross vic summation of mi. Do make observation. Very, very good concepts are hidden here in this derivation. That's why I just picked up here. Okay, let's do one thing. This will rewrite the same formula. I'm going to rewrite. Now, what is VIC? What should be the VIC? Linear velocity of the ith particle with respect to center of mass. And what it should be equal to RIC omega c from circular motion. RIC omega c. V equal to R omega. What is VIC? Velocity with respect to center of mass. That should be equal to RIC, that one. Because all points are rotating about center point in angular velocity. What is the linear velocity of the particle with respect to center? We do write like this. So therefore, this VIC and how RIC and VIC are there? They are perpendicular. They are perpendicular. So what is the angle between VIC and RIC? Must be perpendicular. So therefore, the first expression after expansion, it will become RIC. VIC will become RIC omega c. Summation of this will be mi RIC cross VC bar. If you want, you write. No problem. That is. No. Just wait. Everything is fine. Just listen. Please don't ask anything. In the end, you can clarify. Summation of this will be mi VC plus this will be the expansion of this will be RC cross VC bar. I'm writing this in the convenient form. This is what mi RIC square omega c or this, and all particles will have same angular velocity. This is now I'm entering into the real part of the discussion. About with respect to center of mass, all particles will have same angular velocity. Like that, you take ith particle, jth particle, kth particle, like m1 r1 square, m2 r2 square, m3 r3 square, like that. Different particles will have different mass, different distance. They'll be from the center of mass, but all particles will have same angular velocity. So therefore, what is omega c will be constant, will be same. I'll take outside. Now, what is RIC? We can write it as RI minus RC. The second bracket, I'm going to expand it. This will be Ri minus Rc cross Vc plus. This will be, what is momentum with respect to center of mass? Should be 0. I'll put in bracket so that it will flash for you like a, what I did replacement. Momentum with respect to center of mass must always be 0. Then afterwards, this should be RC bar. Now, what should be the summation of Mi? Summation of Mi should be equal to M, no? Okay, no. Summation of Mi RIC square. What should be written this one? This should be equal to moment of inertia about center of mass, or about with respect to ground. No, with respect to center of mass. So this quantity I'm replacing with the suitable flower brackets that you have to make understand. So that this will let it be this one as it is here. So this will become, if I expand this, so what is the equation? We'll get it MI RI, this is minus RC summation of MI cross VC. And anyway, this is 0. This will become RC or M into RC bar cross VC bar. I think there's no problem with the last one and there's no problem with the first one. So further, this will become, of course, it's a vector. Later on, I'll show the signs. So this will be, okay, the bracket term will have them. So what do you mean by summation of MI RI? So this should be equal to M1 R1 plus M2 R2, M3 R3, and so on, minus. What do you mean by summation of MI RC into M? Now tell me, like, so if you are, so like where the vectors gone, okay, I'll bring the vectors here. Okay, now tell me, like, what is this square bracket term? What is RC bar is equal to M1 R1 bar plus M2 R2 bar plus M3 R3 bar by M. So what will happen to that, the whole bracket term, account from the definition of center of mass? I think summation of the next step, let me write LG, that is. No, this will be IC omega C. So this should be 0, no, again. So this, no sir, I want the sign. So why you are removing that sign? Omega C bar, you can bring it that sign if you want. So this will be, so final equation will become LG is equal to IC omega C. I'll show in the sign, everything I'll show it clearly. So this you can write in vector form, LCM bar plus M into RC cross VC. So what is the angular momentum of the rigid body which is having a rolling motion? Angular momentum due to rotational motion about center of mass plus angular momentum due to translative motion about translative motion of center of mass. How we should interpret this? I think this week what happened, our discussion just revolves around this particular formula. So what is this? Angular momentum. I'll write down the statement. Angular momentum of a rigid body about an axis passing through point G and perpendicular to plane of motion. So what this should be equal to? Angular momentum of rigid body due to about center of mass C due to rotative motion. And what about this? Angular momentum rigid body due to translative motion. And we'll describe translative motion, center of mass. Angular momentum of rigid body about an axis passing through like a center of mass, that one. Because all points will rotate about axis passing through center. Therefore, we'll write this as LCM. So this is one basic core idea of this entire rolling motion. books that directly started with this formula. Tomorrow, if I ask you any conceptual question, I don't think so you can answer it. There's a basic method. See, I think everyone has seen the vehicle's movement. So in the way, when we look at the wheel of vehicle, what you see, all points are rotating about the axle of the wheel, and the center of mass of the wheel workman will move translation. That's what happens here. Finish. That's why I told you, like, you must purchase any one toy and make observation rather than fighting with ear. You must have noticed that what is that rolling motion. Otherwise, without that general idea, not possible. See, mathematically, how much you try to accept, you must have that physical sense, no? A bracket term definition of center of mass. What is the definition of center of mass? So therefore, the bracket term will become 0. Okay, now let me directly get into how to use this formula. So still, I think, okay, we just somehow derived it. Okay, let's see that how to use this formula. I'll give several examples directly. There is a rigid body which is having a